aromatic chemistry, the chemistry of rings like benzene. Specimen 0.5, paper 2. Okay, we've got a reaction pathway. It's got a benzene ring in it. I don't think the first bit is about benzene ring. A suitable reagent for step 1, CH3COCl. That's a chemical called an acyl chloride. That's ethanoyl chloride. What mechanism for ethanol chloride? Addition elimination, always addition elimination. It wants a mechanism. So how does addition elimination work? Well, you've got the ethanol chloride with the COCl. The first thing is something comes along with a lone pair of electrons. So there's a lone pair of electrons on the NH2 of the aminobenzene. I've just simplified it because I couldn't draw the benzene ring, and I've put it C6H5NH2. But the lone pair of electrons on the N bonds to the C of the CO. There's a delta plus on that C after all, and there's delta minus on the O. Lone pair of the bonded pair of electrons in the C double bond O goes onto the O. That's always what happens first of all with addition elimination. And the N will bond on. The O gets a minus charge because that electron's moved onto it. The N gets a plus charge because that electrons move away from it. And then for the second step in addition elimination, now we've added everything together, we eliminate, and we need 3 arrows. The lone pair of electrons, not the minus charge on the O, the lone pair of electrons on the O goes back to form the C double bond O. The Cl comes off, so the CCl bond breaks. Now I've taken that from the mark scheme, I've lifted it from the mark scheme. I'm not happy with it because that arrow from the C to the Cl is not touching on the CCl. So I would take a mark off there, not touching the CCl bond and then going on to the Cl is correct. And again, maybe just slightly, the H breaks off, and it's going to make HCl, or H plus Cl minus. Hydrogen chloride is white steam fumes. That's why ethanol chloride is so dangerous. It will make hydrogen chloride gas. But again, I'm not particularly happy. I can see there's a little gap between the arrow, between the N and the H. I want that touching the bond before it goes on to the N. And then it reforms and makes CH3CONH C6H. It will be C6H5. Okay. And it will make H plus and Cl minus, which will make hydrogen chloride gas, HCl. Let's actually have a look at a reaction involving the ring now, the benzene ring. So concentrated nitric acid and concentrated sulfuric acid. It's not asked for this reaction, but it often does. HNO3 is nitric acid, H2SO4 is sulfuric acid. It's going to make an NO2+. How do I know it's making an NO2+? Because it wants NO2 adding to the ring. NO2 adds to the ring, and whatever you add to the ring, the NO2 has to have a plus for the mechanism. So it makes NO2+. It's going to make water. Obviously, there's hydrogens and oxygens around, and what's left over? Something that's minus to counteract the plus on the NO2+, and there's a hydrogen, an S, and an O4, not accounted for, hydrogen sulfate, HSO4-. You need to learn that. Then the reaction is that the NO2 goes onto the ring and releases an H+. Where's the H+ come from? It's come from the point where the NO2 has gone onto the ring, because there's been an H there, and there's a mechanism whereby the arrow comes from the ring, joins to the NO2+, attacks the NO2+, the NO2+ goes onto the ring. At carbon number 4, I've put it, there'd be an H bonded there as well. There'd be a horseshoe with a plus in the ring, a horseshoe shape instead of the ring, instead of the circular ring, there'd be a horseshoe with the 2 ends of the horseshoe not going too far, in a sort of semicircle really, with the gap down towards the NO2, and the H would break off from the bond with the arrow going into the ring. Give that with a mechanism. Name the mechanism electrophilic substitution. Why substitution, not addition? Because the NO2 has replaced an H on the ring. Why electrophilic? because the main organic species, which is that benzene ring, is donating electrons to the NO2+, which is an electrophile, an electron lover. It's an electron acceptor from the benzene ring. Type of reaction occurring in step 3, I don't know. The peptide bond, the NHCO, has been broken. It's been broken. If that's been broken, it's a peptide bond or an amide bond. Peptide bond that's been broken, and if you remember back to DNA, you use water to do that. You're going to need concentrated hydrochloric acid as well. A reaction involving water is hydrolysis. It means hydro means water, lysis means to break a bond. From Greek, breaking a bond with water, breaking a peptide bond with water, but you need concentrated hydrochloric acid to catalyse that reaction. Identify the reagents used in step 4. What's step 4? An NO2 is going to NH2. You're replacing O's with H's. Anytime you want to add H's onto something, or replace O's with H's, then your answer is always hydrogen and nickel. The mechanism, if you ask for the name of the mechanism, is hydrogenation. Nickel is the catalyst. Hydrogen is added onto something or replacing an O or O's. Hydrogenation using hydrogen